So in the last class we were talking about torque, and this actually creates the rotational effect on a rigid body. So if this is that rigid body and we are applying force somewhere here, and this is axis, then this force F and this R N, this vector R, we have this torque tau. Torque tau is equal to R plus F, which is equal to RF sin theta, where this theta is the angle between these two vectors. So this is n cap to give the direction, and the direction of this torque, this is perpendicular to R and F, and we have that right hand rule, thumb rule, to give the direction of this torque tau. And we know that unit and dimensions for this and that. So this is this axis, rotational axis, around which this particular body is rotating. Then we have defined another physical parameter in the rotational motion, and that is the angular momentum. So this angular momentum, it is defined as, it is represented by L, and this is equal to R cross P. So this R is again like the displacement vector, and P is the linear momentum, where P is equal to mass multiplied by phi. So this is again this L, it is equal to Rp sin theta with n cap, just analogous to the first one, the vector product of this R and P. This is L, and again the direction of this n, it is n cap is n cap gives the direction, and again we will use the right hand thumb rule, the screw rule, to give the direction of this n. And we have the relation between these two, and for which we use simple notion. This if you have this, take the derivative of this dl by dt, it is equal to d by dt multiplied by r cross p, and then we use differential formulation, that is r cross dp by dt plus r, this is dr cross by dt multiplied by dt, and this is r cross f, and plus dr by dt is v, and cross mass multiplied by phi. Here I am putting this p is equal to m multiplied by phi. So this tau, this is dl by dt, this is equal to r cross f, and here this mass is constant, so v cross v is equal to 0. So this is equal to 0 because this is the cross product of two same quantity, and this is equal to tau. So this is a simple method to derive this relation, this rate of change of angular momentum. This is actually equal to the torque, and this is analogous to the relation of linear momentum with the force. So F, it is equal to dp by dt. So somewhat we can say this force in the linear motion, it is just analogous to the torque. Torque is analogous to that force in linear motion. Here this torque is related to rotational motion. Now we will try to derive the relation of this torque with angular velocity. This is the relation between torque and angular momentum. So let us try to derive one relation between torque and angular velocity. So this is that body, and this is that axis, and this body is rotating like this. And if we think about one center of mass somewhere here, it is at the distance of r from this, it is rotating. Now we may have two cases. First, if this body is just following a circular path of radius r, and this the case we have also discussed in circular motion. So when we were talking about that circular motion, this is that circular path of radius r, and one body is somewhere here. If its velocity is constant, angular velocity omega is constant, just the constant velocity, then we have one centripetal acceleration. I think you remember this, that centripetal acceleration. This was represented by AC. And second, we have discussed about tangential acceleration. It was represented by AT. We have two types of acceleration discussed in circular motion. One is the centripetal acceleration, and second one is the tangential acceleration. If this body, this is rotating with a constant speed, the velocity is changing because of change in direction. It is just rotating with a constant speed. Then we have this AC. AC, this is equivalent to, this was equal to V square by R. And that centripetal force we have defined, that is Fc. It is equivalent to m V square by R. This is that centripetal force. And this is V square by R. This is that AC, centripetal acceleration. And the direction of this centripetal acceleration, this is toward the center. That's why this is known as centripetal. The direction of that acceleration is toward the center, as well as this, the direction of this force, this is toward the center. In the cases, that system is moving with a constant speed in a circular path. Just with a constant speed. Okay? And one can write this in terms of omega also. This is equal to, V is equivalent to omega r, or omega is equivalent to VR. What is this? V is equivalent to omega r. So this is equivalent to, what will be this? Omega r square. Omega square r. So this AC, this is equivalent to omega square r. Our force Fc, this is equivalent to m omega square. And the direction is toward the center. Second, if this body is accelerating also, means that the speed is not constant, that the direction as well as magnitude both are changing. Here in the case of the first case, only the direction is changing. That's why the velocity is changing, and this is the concept of centripetal acceleration, centripetal force. And if it's moving with varying velocity in terms of magnitude as well as direction, means that object is moving with like this. Continuously its speed is increasing. In this case, one centripetal force is still in the direction of center, but second as a force, that is AT, because of change in the magnitude of speed, the magnitude of velocity, this AT is generated, and its direction is tangential to this. Okay, so this AT, this is equal to what we have, this, where is that relation? This V is equal to omega multiplied by R, and you want to calculate that acceleration, this dV by dt, it is equivalent to R multiplied by d omega by dt, and this is just that alpha, it is equal to that this is just A, it is equivalent to AT is equivalent to R multiplied by alpha. This alpha is d omega by dt. This is angular acceleration. So this AT is equivalent to R multiplied by alpha. And here this AC is equivalent to omega square R, and this is the force. And here this Ft, the force, the tangential force is equivalent to mass multiplied by R multiplied by. Okay, just think about this. Try to think what is the difference between these two. Okay. Now we will try to calculate the torque in both cases. One torque due to this FC, centripetal force, and second torque with this tangential force. And let's think about this one. So here, this is that object moving around that axis. We will have two acceleration. One is this AC toward the center, and second, this is AT tangential to that. So accordingly, the force will be, that force is FC along this toward the center, and second force that is FT, that is in the tangential direction. So when we try to calculate this torque, so here torque is equal to this torque tau, this is equivalent to R multiplied by F. Just I am talking about RF, R cross F, let's say R cross F. So this is tau C, this is FC, and this is equivalent to R cross this FC, R FC sin theta, and here theta is equal to, it is just toward the axis, this is that axis, theta is equal to 0, so theta is equal to 0, and when theta is equal to 0, this tau, it is equal to 0. Okay, just you can think, just we are trying to pull this door toward the axis. So when we apply that force toward the axis, then the total torque will be 0. Why? Because this will not create any turning effect. Torque is actually defined for to create that turning effect. When we apply that force toward the axis, there will be no turning effect, means there is no torque. So in case of that, when this centripetal force, there will be no turning effect, there will be no torque. But here, if this is that AT, for this AT will have, so you can write a single line for this. Since the direction of centripetal force is towards the axis of rotation, therefore there will be zero torque or no torque generated by it. So there will be no turning effect, there will be no torque generated by this. Now torque due to tangential force, that is tau, it is equal to R cross FT. This is RF T sin theta, and here theta is 90 degree. So this is RFT, and this FT is here MR alpha. So this is R multiplied by MR alpha. And this is equal to MR square alpha. This alpha is angular acceleration, and this is the relation between torque tau and angular acceleration alpha. And this MR square, this actually defines another important physical parameter we will discuss in next lecture. And this MR square is denoted by this MR square, it is denoted by I. We will discuss this in the next lecture. This is known as moment of inertia. This is moment of inertia. And this tau, this is equivalent to now I alpha. Okay, now to convert this for n-body system, we have calculated this for a single center of mass or single point system. Now you can convert this for the n-body system. We have n particles, and for n particles, for n-body system, for a rigid body of n particles, now tau is equivalent to R cross F tau I. Total tau is equal to summation of Ri F Fi. In terms of cross, I should write Fi. I is equal to 1 to n body system. For rotational motion is Fi can be written as the sum of Fc plus Ft so this is I is equivalent to 1 to n or I cross Fc plus Ft. So this is summation of I is equivalent to 1 to n or I cross Fc plus summation of I is equivalent to 1 to n or I cross Ft. This is equal to 0. This is equal to 0. You can write this R cross Fc. Yeah, or you should write, since the direction of Fc is applying towards the axis, that is R cross Fc is equal to 0, is equal to 0. So this tau is equal to summation of I is equal to 1 to n, and this is Ri cross Ft. Where Ft is equal to, in terms of angular velocity, mass multiplied by Ri multiplied by alpha. So this tau, this is equal to summation of I is equal to 1 to n, and this is Ri cross Ri Ft sin theta, and theta is 90 degrees. So this is equal to summation of I is equal to 1 to n Ri, and here this is mRi alpha I, and this is summation of I is equal to 1 to n, and this is mRi square, mi square multiplied by alpha I, and this is just I, moment of inertia, and this is alpha. Okay, so this is tau. So that I is the moment of inertia of the complete body to the center, and this alpha is that summation of angular acceleration. So do not hesitate to write for n-body system. Just there is one single change in that equation, that you have to take the summation term. Otherwise, all the physical calculations, physical formula are identical. Just start from one single particle and convert transform that for n-body system, and this is that. For complete body, just we can write this. I just write like this. This I is equivalent to 1 to n mi I square is equivalent to I. And the summation of this, summation of alpha I is equivalent to alpha. Overall, this combined system. So we can write this alpha is equivalent to. Now we can use this formulation technique for the relation of angular momentum and torque also. So for n particle system, that the angular momentum L is equivalent to R cross P. So this will be L is equivalent to summation of y is equivalent to 1 to n R I cross Pi. So by differentiating this dl by dt, this is equivalent to d by dt summation of I is equivalent to 1 to n R cross Pi cross. Just convert the complete thing for n particle system, because in this chapter we are dealing with that n particle system. So this is equal to summation of I to 1 to n Ri cross dpi by dt plus, and this is equal to summation of I is equal to 1 to n R cross Fi, rate of change of momentum, this is force, plus this is dr by dt is di cross m di. Again this is equal to 0. So this dl by dt, it is equal to summation of I to 1 to n, it is R cross Fi. Okay, now if you remember this force F for n body system, we have divided this force into two parts. One internal force and second one is external force. In the previous linear motion case in body system, this Fi, this is written as equal to F internal plus F external. F internal means in between terms, that is internal force applied by that neighboring particles. If this is that particles and this is that center particle, so neighboring particles are applying force. So that is the internal force, and that external force we are applying to rotate that body or translate that body, that is the external force. So this total force Fi, this is actually the sum of internal force and external force. Internal force is because of that neighboring atoms, and external force is that external force we are applying. So just we can write this Fi is equal to F internal plus F external, this dl by dt, this is actually equivalent to I is equivalent to 1 to n R cross, this is F internal plus F external, we can write like this. So this will be equal to summation of I is equivalent to 1 to n R I cross F internal plus summation of I is equal to 1 to n R I cross F. Okay, so this is also that torque due to that internal force, so that is equivalent to tau internal plus this is tau external. And as we have taken in case of force, this internal force, the total sum of internal force is 0. So this tau internal is that will be total sum of that tau internal. that will be 0. As the total internal force on any specific particle in the rigid body is 0. So similarly, this tau internal is equal to tau 1 plus tau 2 plus tau 3, the sum, total sum. So similar to that internal force concept, that the torque due to that internal force means one can say that internal force that cannot create any rotational effect. So the total tau internal is 0. So this implies dl by dt. This is actually because of this external force, and this is equal to external torque. So rate of change of angular momentum, that is the rate of change of external the rate of change of angular momentum of n particle system is equal to external torque. Rigid body system, and for n particle system we have calculated that torque, the angular momentum, and the relation between this angular momentum and the torque, as well as we have the concept of angular acceleration, and that angular acceleration and the relation between that angular acceleration and the torque. And in the next class we will discuss about one new topic, that is moment of inertia, which we have just denoted here, use here, but that is a very specific topic and important also. So I think I should close to this lecture now. Thank you.